All right, graphing equations day 2. Graphing equations day 2. A couple of things we need to review for graphing equations day 2. A couple of things about just the coordinate point, the coordinate plane, we need to remember. Don't forget this is called a coordinate plane. Everybody say coordinate plane. Good. Why is it called a coordinate plane? Because it's a plane. A plane is a two-dimensional surface that goes on forever. It's coordinate plane because there are coordinates you can find on them. X coordinates and Y coordinates, right? A couple of things that we need to remember. Origin is at the center. What's the coordinates of the origin?
0.
Almost. What's the coordinates of the origin? 0, 0, because you go 0 horizontally and 0 vertically. The x-axis and y-axis are the zeros here and the zeros here. So any number that's on the x-axis has a 0 y value. Because any number that's on this x-axis did not go up at all. So it has a 0 y value. Any point on the y-axis has a 0 x. Because it moved left or right 0 spots, right? So those are the 0 lines. Ordered pairs consist of an x and a y coordinate. Don't forget that. Ordered pairs, x comma y. We talked about that yesterday. The x coordinate tells you the horizontal direction. Don't forget positive, negative. Y coordinate, vertical, positive, negative. And don't forget about the quadrants. You got quadrant 1, 2, 3, and 4. Quadrant 1, 2, 3, and 4. Remember, it makes a C for coordinate plane. Helpful technique to remember where those points are going to go is by recognizing the positive and negative numbers in each quadrant. Quadrant 1 is both positives. Quadrant 3 is both negatives. Quadrant 2, negative x, positive y. Quadrant 4, positive x, negative y. It might be helpful to write those in. It would be a good idea to remember, all right, how do I plot these points, making sure that I get them plotted correctly. All right, so let's go over our steps to graphing equations. So, a couple things that we need to do. We need to make a table and choose 3 points, but you want at least 3 points, right? 3 or more. If you don't like the length of your line after 3 points, pick another one. It's all good. Just add another one to your table. There's no problem with that. Complete the table to find 3 solutions. Who can remember, or who can just look backwards in their notes, what a solution is? What is a solution? Ashley?
An ordered pair that makes the equation true.
Exactly. So we need to complete the table and find 3 ordered pairs that make the equation true. Then we graph those points using our ordered pairs, our x and our y. Lastly, bless you, if you have a straight edge, today would be a good idea. A straight edge is anything with a straight edge. You might have heard them called rulers before. Or this piece of paper. Or this piece of paper. Or anything that has a straight edge. If you guys have an iPad case that has a nice edge that you can draw on, that's cool. If you have a credit card or something, hopefully you don't, that's a straight edge. So get something out that has a straight edge. It can be the edge of a binder. I don't care. I usually use a see-through ruler, if possible. When I'm drawing on my iPad, I usually have to use a Post-it because I can't draw on my iPad very well. And then lastly, to make something a line goes on forever, so you have to make sure that there are arrows on it. That line, once again, should go on forever. So if the coordinate plane is this big, your line needs to go all the way through the coordinate plane. If we have 3 points and they're right here, here, and here, our line better not be this long. This is why you have a straight edge. You do not make a line like this. If you have 3 points and they're right here and here and here, your line goes here with arrows at the bottom and arrows at the top. Your lines need to pass all the way through the coordinate plane. Think of this as like a window. And your line is like a road. If you want to look outside that window and you see the road, that road will go from one end of the window all the way to the other, right? And you'll know that the road goes on forever, or well, extends past that window, right? So what you can see when you look out the window at the road is only a portion of it, right? But can you only see this much of the road? Or do you see this much of the road?
See that much?
You see the entire road through the window, which means that your line, whenever we draw our line, it is not to be this small. It is to pass from one end all the way to the other, with arrows at the end notating that it's going to extend past the window. That's how you need to think about this, okay? So I'm just going to go right ahead. I'm just going to do this one. And then you guys are going to do a bunch, okay? So I'm going to demonstrate what I'm looking for.
We don't change our starts as negative 1, 0.
Yeah, I did not change it. I changed yours to have negatives because I wanted you to have negatives in there. Thank you. Awesome. Cool. So what did I change this one to?
-1, and then 0 and 1.
Okay. I knew I changed it because I wanted you to have negatives. Here's the deal. I like these 3 points. Yesterday I presented you guys with 0, 1, and 2. I like these points better because sometimes I need to throw some negatives in. I need to make sure that the line is true over here and over here. Most lines extend forever, right? If they don't extend forever, they're called line segments or rays. So I want to graph this line. Pretty easy. This is a pretty easy one to graph. Don't forget the x values are called our input. Almost. It's almost letting me write the letter N. Nope. Almost. Let's try to do it over there. Nope. Almost. Look at this. I'm trying so hard. Yes, all right. It finally let me. Did you guys see that? That was crazy. This is where we do our work. This is our output. This is our solutions. So we're going to fill out our table, and then we're going to plug them in. Now here's the deal. Whenever I plug in a negative, I always want to plug in my negative with a set of parentheses. I'm going to be honest with you right now, it's not going to matter on this problem, but it will when you have multiplication. Okay, so don't forget to plug in with parentheses when you have the multiplication. -1 plus 1 is 0. So our coordinate point is -1, 0. And let's plot that. So that means I'm going to go to the left 1, and I don't go up at all. Bless you. Bless you. That's where the point -1, 0 is. I'll zoom in on that so you guys can see it. -1, 0. Because it's -1 in the x and 0 in the y. Do not confuse a coordinate point with slope. Okay? Do not confuse a coordinate point with slope. Remember, slope is rise over run, right? Do not confuse coordinate points with slope. Slope is rise over run. It's a fraction, not anything to do with the coordinate point. All right? And now I'm going to blast through the rest of them, because y equals 0 plus 1 equals 0. Excuse me, not 0. It equals 1. So my point is 0, 1. So I move 0 in the x, and I move up 1. Y equals 1 plus 1, which is 2. So 1, 2. And there it is. Now, I have those 3 points. My line needs to fully extend all the way through that entire window. If I think I might have trouble with that, I could pick a number all the way over here and plug it in and create another point all the way over there to make my line a little bit easier to graph. You need to use a straight edge. So get out your straight edge. Mine is this post-it note. And it has to connect all the way through. Typically, a straight edge is nice and solid, so it doesn't bend. My post-it note is the best I can do. Notice now, for some reason it was all wiggly. I don't really know why. It does that on mine, but it should not be wiggly. And notice how it extends all the way through the window. That is what I expect. Okay? That's what I expect.
I would.
Questions for me? Questions for me on this? Yes, sir. Yeah, if you want to add another point on here, sure. Let me add another point. Be like, all right, I want to get one all the way over here. I'm going to add 7. So, 7. Y equals 7 plus 1, which is 8. So another point would be 7, comma 8. So I go over to 7, go over to 8, and there we go. If you don't like the points I've given you, just add another one. There's nothing wrong with that. There's nothing wrong with that at all. Okay? It makes, to be honest with you, it makes it easier to graph when you have points that are a little more spread out. But I always think it's in your best interest to get points close to 0 to make sure that you're set with that way. Okay. Now I think I changed these numbers as well.
Yeah,
Negative 1, 0, and 1. And then on number 3, what did I change them to?
Exact same.
Are they the same?
No, negative 2, 0, 2.
Why on number 3, and you guys are going to do these in just a second, why on number 3 did I change it to negative 2, 0, and 2, rather than negative 1, 0, and 1? Steven?
It's negative 1, 0, 1.
On number 3?
Yeah.
Okay. So what should you change it to?
Negative 2.
No, number 3. Number 3. Once again, on number 3, why did I change it to that? Tori?
Because it's a fraction and
It's over 2, so we want to get multiples of 2. Careful when you plug in the negative, make sure you plug it in with parentheses. Same sign positive, different sign negative, right? Make sure you do that. Okay, so let's have some volunteers. We're gonna skip one of them. Which one do you want to skip? Let's go with. Let's just do one. Let's do number 2. That's the first time we've seen a negative coefficient. Kobe, let's do the first one for us.
Alright, so y equals negative 5, and then parentheses negative 1.
Good. Thank you for saying parentheses.
And then, I don't know if you would do this, but would you do the negative in here? Or the,
No, because there isn't a negative negative.
not?
No.
Alright.
This is multiplication, not addition or subtraction.
Alright, so what you would do here is you would get positive 5 because you have 2 negatives and you multiply those. Then you get what's it called? You get a positive.
You get a positive, right?
Yeah.
Same sign, positive. Right? Because they're same sign. Cool.
And then you got like parentheses and negative 1, comma 5.
Good. And that is over here, negative 1 in the x and 5 in the y. So it's up there. Jory?
Okay, so the second one, you do y equals negative 5 parentheses 0. And then that would be just 0.
Yep.
because-
Because 0 times anything is 0.
And then you put on the coordinate 0, 0 would be what the origin.
At the origin, absolutely. And then the last one, pretty easy. 5 times 1 is 5. And we get 1 comma 5. Told you, if you write fast, this stuff goes fast. Now the careful thing is, what mistake did I just make? And I did it on purpose. What mistake did I make? The 5 is negative. So what did I do? I went fast, but I went a little too fast. So that's one of those things I want you to be aware of. I want you to be aware of the fact that writing fast is important on these, because if you write faster, these problems go faster. But the key on this is making sure you actually include negatives when they're supposed to be there. And we graph this one.
You still didn't put the negative in the parentheses.
I didn't. Okay, thanks for the heads up. There we go. I was trying to get the line done. Ah, darn it. All right, so no more post-it for me. I'll just have to draw really slow. No more Post-it for me. All right. And I'll just have to go real slow. Make sure your line goes all the way through. Go ahead and do 3. I'm going to skip it, but if you've already worked ahead and you've gotten number 3 done, I'm going to show you what it should look like. A couple things. The reason why we picked -2, 0, and 2 is because when you multiply 1/2 by those numbers, it makes your life a little bit easier. Right, half of -2 is -1 plus 2 is +1. And your graph should look like this. Let's get to the ones where you choose your own points. Okay? For time's sake, let's just choose our points. What points do you think would be a good idea to choose for number 4? Landon?
-3 to 0.
Yeah, I agree. Because those are multiples of 1. Excuse me, multiples of 3. They're multiples of 3, and why do we pick multiples of 3, Landon? Yeah, the denominator is 3, and 1/3 of -3 is pretty easy. What's 1/3 of -3? What's 1/3 of -3? Okay, let's do the easy one first. What's 1/3 of 3? What's 1/3 of 3? What's 1/3 of -3?
-1.
There you go. We already done. We're done with those. What's 1/3 of 0? Perfect. Pretty easy, right? What number should we pick on number 5?
We can pick whatever numbers we want.
We can pick whatever numbers we want. Let's use integers. Let's pick the ones we did yesterday. 0, 1, and 2. If we want to throw a negative number in there, let's throw a negative number in there. Let's throw a -3. Now this one should be super easy. Why? When you multiply by a negative, what are we actually doing? We're not making it negative. What are we doing?
We multiply by a negative.
What happens when you multiply by a negative? No, we don't get a negative. No, we don't get a positive.
It depends on what you multiply by.
Exactly. When you multiply by a negative, what are you actually doing? Well, let's find out. Let's actually do it. So y equals negative parentheses 0. Negative 0 is 0, so we got 0, 0. Y equals -1. Oh, okay, so that's -1. So 1 comma -1. Y equals -2. -2. 2, -2. Then I had you guys add a -3 at the end. Y equals -3. Now, Kobe, negative ninja shows up. Why does the negative ninja show up? Because it's negative.
And then a
Negative.
We can
Hit!
make it
Hit! So, what do we get? +3. So our point is -3, 3. Which means we go -3 in the x, +3 in the y, and it's a point all the way up there. And our graph should look like that. Now I told you I was going fast today. Told you I was going fast. So in the time that we have, I want you to finish the ones that we haven't done yet. I think that was number 3 and number 4. Okay? Now, why on number 5 did I not give you a table, but I gave myself a table? Well, because I want you to be able to make your own table. Okay? How many people made a full-on table with the full-on boxes? That's cool. How many people just made a frame? No horizontal lines. That's cool too. You don't need to make the full-on table. You don't need to make the full-on box. Don't waste your time. Okay? Just make it so it's organized.